Okay, so we're going to be doing the first half of the final exam review, and we're going to be doing questions 1 through 8 in this first part of the review. So let's take a look at question number 1. Now, before we get started, you might want to go through and try these on your own first before you check the answers with this review video. Okay, so let's start with number 1. Determine whether or not the function f is defined by, and we have a piecewise function. Now over here, we have constraints. Right, that tells us what part of the graph that we're looking at. So the first graph, the first line, we're going to only be concerned about when x is less than 3. And the second line, we're going to be concerned about when x is greater than or equal to 3. And the question is this continuous at 3? Continuous, remember, in calculus means that we don't have any holes, jumps, or asymptotes, meaning that if this is a piecewise function, these two lines should meet up right at 3. So to check that, to see if they meet up, what we're going to do is we're going to plug 3 in to each of these formulas and see if they give us the same point. So first I'm going to plug 3 into the top equation. So 3 squared minus 4 times 3 plus 6. So that would be 9 minus 12 plus 6. That gives me 3. The second equation, if I plug 3 in, that's negative 3 squared plus 4 times 3 minus 2. So that would be negative 9 plus 12 minus 2. That gives me 1. So that means this piecewise function does not meet up at the same point. So what we would say is this is not continuous because we have to use calculus to state our answer. So we would say because the limit as x approaches 3 from the left of our function, so this is the left side, does not equal the limit as x approaches 3 from the right. And this is the right. So this is exactly what you want to state. Now, if they were equal, you would say it is continuous because the limit as x approaches 3 from the left is equal to the limit as x approaches 3 from the right. My dog is being loud. Okay, let's go to number 2. Number 2, we have a limit question. So we have this graph over here and all sorts of questions about limits. Now, limit is the height that you're intending to reach. So number 2 is asking about the limit as x approaches negative 2. So here's negative 2. What height are we approaching at negative 2? The height we're approaching is 1. Now it doesn't matter that it actually doesn't exist there. We just want to know where it's headed toward. Okay, number 3, the limit as x approaches negative 1. Oh, sorry, that says 1, and then this little negative here means from the left side. So I'm going to find 1 right here. I'm coming in from the left side. So if I look at the left side of 1, I look at this line right here, and it's headed toward a height of negative 3. Number 4, we want the limit as x approaches 1 from the right. So from the right side, our height is approaching 1. And then number 5, the limit as x approaches negative 4. So here's negative 4. Now, the left side is going toward infinity. The right side is actually headed toward negative 2. Now, this is just like number 1. They're not headed toward the same spot. So for this one, the limit does not exist. And that's because the function is not continuous. The limit from the left does not equal the limit from the right. Now, if they asked about the left side would be infinity. The right side would be negative 2. Okay, so that's what we spent the whole first unit on. We talked about limits. The second unit we spent with derivatives. So we're going to look at number 6 here. We're going to find the derivative. And we talked about all the different properties. So one was the product rule. So the product rule, and I'm going to write this down, was first times the derivative of the second plus the second times the derivative of the first. So we're just going to follow those directions. Here's the first, and I'm going to use a different color here so we can color code it, and here's the second. So I'm going to start by labeling f prime of x is equal to, so I'm going to start with the first, 2x squared plus 7, times the derivative of the second. The derivative of the second is 2x minus 4, plus the second, so I'm going to rewrite the second, x squared minus 4x plus 2, times the derivative of the first, which is 4x, and that's it. Now you do not have to simplify, so you're going to want to leave your answer just like that. Okay, so let's go on to another derivative here. We're going to be doing the quotient rule. So let's recall the quotient rule. That was our fancy ho-de hi minus hi-de ho over ho-ho. Okay, so let's go with f prime of x, and I'm going to label the top pi and the bottom ho. Okay, so ho-de hi, we're going to do ho, x squared plus 1. D hi would be 2x plus 3 minus hi, x squared plus 3x minus 4. D ho would be 2x over the bottom squared. And again, you do not have to simplify, so I would leave it like that. In AP Calc, we never simplify because if you make a mistake, you're going to lose points. So it's the same for any kind of class. If you don't have to simplify, don't do it, because if you do simplify and you make a little mistake somewhere, you lose a point. So you might as well not simplify. Okay, so let's go on to question number 8. Question number 8 is a chain rule. Now, we've talked about this lots of times, that whenever we have a square root in a problem, first thing we always want to do is rewrite the problem. And we want to write it as an exponent. Okay, so this is a chain rule because we have an inside part. So if you remember the chain rule is the derivative of the inside times the derivative of the outside. Okay, so I'm going to just follow those directions, and I'm going to first take the derivative of the inside. And the inside is typically always parentheses. If it's a fraction, it's going to be the denominator. If it's a radical, it's going to be the part underneath the radical. So always pick, when in doubt, if there's parentheses, go with what's inside the parentheses. So I'm going to take the derivative of the inside, which is 15x to the 4th minus 6x squared. And it's a quantity, so I'm going to put it in parentheses, times the derivative of the outside. So if this was just x to the 1/2, right, we'd use our power rule. We'd multiply and then subtract by 1. So I'm going to do the same thing. I'm going to multiply 3x to the 5th, rewrite the inside part, minus 2x cubed, and then subtract my exponent by 1. So that would give me negative 1/2. And that one is complete. So that concludes part 1 of the review sheet. So now if you want to work ahead on your own, go ahead and try the rest of this. And a lot of this is recent material, so this next part hopefully will be a little easier for you guys to remember how to do. So now go ahead and try questions 9 through 14, and then watch the second part of the video to see what the answers are.